Now we look at example 6.2. So the first thing is we need to understand the problem first. So now we look at a physical situation. So water flows steadily into a reducing elbow. As the water pass through the elbow and the pass size becomes smaller and the flow is turned upward by 30 degrees. So the data given, the mass flow rate of the water in 14 kg per second. The inlet cross-sectional area is 130 square centimeter and the outlet cross-sectional area is 7 square centimeter. So for the inlet and outlet cross-sectional areas, we using A1 and A2. And then we move to how to find the velocities. So if we need to find the inlet and outlet velocities, we need to apply the continuity principle. So for continuity equation, will be mass flow rate is equal to density multiplied by cross-sectional area multiplied by velocity. And then to find the inlet velocity, we rearrange the continuity equation. So inlet velocity equation will be inlet velocity is equal to mass flow rate divided by density multiplied by inlet area. And then after we substituting, the final answer for inlet velocity will be 1.24 meters per second. And then the outlet velocity, we use the same equation. So will be outlet velocity is equal to mass flow rate divided by density multiplied by outlet area, and the last the final answer for outlet velocity equation will be 20 meters per second, and this show that velocity increase significantly has the area decrease. And next we apply Bernoulli equation between the inlet and the outlet to find the inlet pressure. So Bernoulli equation must be pressure energy per unit weight plus kinetic energy per unit weight plus potential energy per unit weight at the inlet is equal to pressure energy plus kinetic energy plus potential energy at the outlet. So since the outlet pressure is atmospheric, the gas pressure at the outlet is 0, and after we substituting all the value, so the final answer for inlet gas pressure will be 202.2 kilopascal. By applying the momentum equation to determine the force required to hold the elbow in place, we apply the linear momentum principle. So we resolve this equation into horizontal and vertical direction. So we need to know first horizontal and vertical direction first. So horizontal show x direction and vertical show z direction. So first we consider the horizontal direction first. Horizontal momentum equation will be the supporting force in the horizontal direction plus the inlet pressure force is equal to the momentum correction factor multiplied by mass flow rate multiplied by the outlet horizontal velocity minus the inlet velocity. And then after we substituting the value and solving, so the final answer for horizontal direction will be 2053 Newton acting to the left. So the negative sign indicated that the actual direction of the force is opposite to the assumed direction. And next we consider the vertical direction. So vertical momentum equation will be the supporting force in the vertical direction is equal to the momentum correction factor multiplied by mass flow rate multiplied by the outlet vertical velocity. And then after we substitution and calculation, the final answer will be 144 Newton acting upward. Now we move to example 6.4. So example 6.4 show water jet striking a moving cart. So now we need to understanding the physical situation first. So first let us understand what is happening physically. Water is accelerated by a nozzle and form a jet moving at 35 meters per second, and this jet strikes the back surface of a car, and the car is already moving forward in the same direction as the jet at a constant speed of 10 meters per second. And after the jet hit the car, the water spread out in all directions along the surface of the car. This means that after impact, the water has no velocity in the horizontal direction. Horizontal direction will equal to frx or x direction. And then because the water change is a velocity when it hit the car, its momentum change. This change in momentum produce a force on the car to keep the car moving at constant speed. A braking force is required. So we look at the data. So the data given, the velocity of the water jet is 35 meter per second. The velocity of the car is 10 meter per second. The mass flow rate of water leaving the nozzle is 30 kilogram per second, and the motion is horizontal. Now we need to find how fast the water jet approaches the car relative to the cut. So relative velocity equation will be relative velocity is equal to jet velocity minus cut velocity. So after substituting value, we will cut 35 meter per second minus 10 meter per second. So this means that from the car point of view, the jet approaches at 25 meter per second. And then effective mass flow rate striking the cut, not at all the water leaving the nozzle strike the cut with the full nozzle velocity. We must adjust the mass flow rate based on the relative velocity. So mass flow rate relation will be the mass flow rate striking the car is equal to relative velocity divided by jet velocity multiplied by the nozzle mass flow rate. And after substituting, will be 25 divided by 35 multiplied by 30 kilogram per second. So the final answer will be 21.43 kilogram per second. And then we apply the linear momentum equation in the horizontal direction. So momentum equation will be the sum of external force acting on the control volume is equal to the mass flow rate multiplied by the outlet velocity minus the inlet velocity. And then after the strike the car, the water has zero horizontal velocity, therefore the outlet velocity is zero. So the only horizontal force acting on the car is the braking force. We add opposite to direction of motion. And then next step is force equation. So force equation will be the braking force is equal to negative mass flow rate multiplied by the relative inlet velocity, and then after substituting will be negative 21.43 kilogram per second multiplied by 25 meter per second, and the final answer will be negative 535.8 newtons. So negative sign means to the force at opposite to the direction of motion, and final braking force will be 536 newton. And then power is the rate at which work is done. So power equation will be power is equal to force multiplied by velocity, and after we substituting 5 will be 535.8 newton multiplied by 10 meter per second, and the final answer will be 5358 watt. And then if the brake fail, the force from the water jet will be accelerate the cut. So Newton's second law will be acceleration is equal to force divided by mass, and after substituting will be 535.8 newton divided by 400 kilogram, and the last answer will be 1.34 meters per second square.